Hello everyone. So in this video we will be solving assignment 11. So let me show you the questions first. So these are the questions. Okay. And this is a very good question actually. Then there will be a last question. So these questions are there. So this will be solving. Okay. So yeah. So this is the first question. So this is the input given. What is Vt? Vt is simply 3 of u minus t, and after t equals to 0 it is 6 ut, right? So for t less than 0 what will happen? At t equals to 0 minus, steady state would have been reached. Would be reached, right? Steady state would have been reached. So like 3 volt is applied for a very long time, so steady state would have been reached and this inductor would be short circuited, right? At steady state inductor is short circuited, so inductor would be short circuited. So basically you have 3 volt, and in case of inductor, what we are interested in? We are interested in finding the 3 volt, and R is in the series actually. We are interested in finding the current because it has the property that it doesn't change the current across it instantaneously. So we'll find the current. And this is the case only, no? Yeah. The inductor is shorted. So 1 ohm, 1 ohm, 1 ohm, and this is the current I of 0 minus, right? I of 0 minus would be 2 ampere, that would be divided into 1 ohm and 1 ohm. Like you can find it, right? The current you can find in this circuit. If they ask you to find the current, you can find that, right? It would be 0.5, it would be 1. So 3 by 1.5, that means 2 ampere current, that would be divided between 1 and 1. So it would be simply 1 ampere. So the current it is carrying is 1 ampere. So after t greater than 0, what is happening? The same circuit is there. We have 6 volt. We have a resistance. We have another resistance. We have an inductor. Value of the inductor is 1.5 Henry. And we have a resistance. But now there is an initial current. The initial current is what? 1 ampere, right? What do we need to find? We need to find the IT at t equals to 1 ampere. Okay, so initial current is 1 ampere. So I of 0 plus would be 1 ampere. What would be I of infinity? It would be 2 ampere. How did I write it so quickly? The same circuit is there. At I of infinity, the inductor will be shorted, right? Inductor will be shorted, and this same circuit will be there, right? The same circuit will be there at t equals to infinity. This 3 volt will be replaced with 6 volt. This inductor will be shorted 1 ohm in parallel, and 6 volt is there. For 3 volt we were getting 1 ampere, for 6 volt we will get 2 ampere. Which theorem is that? Linearity. For the same circuit, I just increase the input, so I will get 2 ampere. Or you can simply find at a steady state the inductor will be shorted, so 1 into 1, this would be 1.5, so 4 ampere current will be flowing, and 4 ampere current will be divided into 2 parts, so 2 ampere current will be there. So this is the current. So what will be your IT? At steady state it is 2, and initially it is 1. Okay, and what is the time constant? That is L by R, right? L is 1.5 and R is 1.5, so that is 1 second. Okay, what is the time constant? L effective by R equivalent, right? R equivalent is 0.5 plus 1, 1.5, and L effective is 1.5. 1.5 by 1.5, 1 second. Okay, so 2 into a to the power minus t ut, and they asked you to find the value at 1 second, right? So 2 into a to the power minus 1. So let me find the value. 2 by e, it would be actually 2 minus 1 by e. Reciprocal of e minus 2, 1.63. So 1.63 ampere is your final answer. Okay, well and good, easy question. First you solve for the t less than 0, 3 volt. Because of 3 volt, there would be current that would be set up, the setup current is 1 ampere. The current is set up for 1 ampere, then for t greater than 0, initially we are having 1 ampere current, at steady state the inductor will be shorted, so the current would be 2 ampere. So you can simply write the equation for time constant. You find L by R is 1 second. So you just wrote down the equation and then you needed to find the current at 1 second. So it would be 1.63 ampere. Okay, well and good. Let's move on to the next question. You have to find V naught t at t equals to infinity. So find V naught t. So I am just changing this question. First you will write the expression of V naught t and find V naught infinity. Okay. So in the question, if they had asked you to write the expression of V naught t, what would you have you done? Look, first we will write V naught infinity. V naught infinity we will find. Okay. So at t equals to infinity, what is happening at t equals to infinity? Inductor is shorted, right? Inductor is shorted. So what I can do, so I will have to make the circuit again. Inductor is shorted. This is 5 ohm and this is V naught of infinity. V naught of infinity. This is 2ix, right? And this is 10 ampere. You need to find the value of ix. Basically, if you find the value of ix, that would be good enough, right? Because V naught of infinity is what? V naught of infinity is 5 into ix, right? Now, what you can do? You can apply nodal here. So, V naught minus 2ix by 5 plus V naught by 5, or simply write ix plus ix. What did I do? First, I wrote the current in this branch. If this is 0, this would be V naught infinity minus 2ix by 5. I should have written V naught infinity. V naught infinity minus 2ix by minus 2ix by 5 plus ix current that is going outward, and 10 ampere current is coming inward. So it would be 10. So it would be V naught infinity plus 3ix equals to 50. V naught infinity plus 3ix equals to 50, right? Equals to 50. What is V naught infinity? This is equation 1. So V naught infinity is 5ix. So it would be 8ix. So ix would be 50 by 8 ampere, right? So what would be V naught infinity? V naught infinity would be 5 into 50 by 8. 5 into 50 by 8. 5 into 50 by 8. That is coming out to be 31.25 volt. Look, this is the final answer, V naught infinity. Okay. Now, if they had asked you to write the expression of V naught t, what would have you done? Similar way you find V naught infinity, you could have find V naught 0. Then you needed to find tau. So this you would have done, or you can solve by Laplace. Okay. By solving by Laplace, it will take less time as per me. Okay, I solved it by Laplace, so it took less time. Okay. If you had solved it in time domain, what would have you done? You would find V naught at t equals to 0, right? So at t equals to 0, inductor will be what? Inductor will be open circuited, right? Because initially it is not having any current. Inductor will be open circuited. So ix becomes 0. At that time, ix becomes 0. So your V naught initially would become 0 only. V naught at t equals to 0 would become 0 volt only, because inductor will be open circuited, so it would become 0 only. Now let me think if I am doing it right or wrong. Initially inductor will be open circuited. Okay. If inductor is open circuited, Okay, let's just take it, then we will solve by Laplace transform as well. So my V naught at t equals to 0 is becoming 0 volt. Okay, my V naught at t equals to 0 is becoming 0 volt. Okay, then we will solve by Laplace, and then we will see if I am doing it right or wrong. Did you understand what is happening here? I just made inductor as open circuited. So if it is open circuited, then there is no current flowing through the resistor. So V naught at t equals to 0 would simply become 0 volt. Now let's talk about the time constant. Okay, this is the second thing. Now you need to find the time constant as well. For time constant, what is L effective? That is 2 Henry. Then you need to find R equivalent across that, right? You need to find R equivalent. Across the inductor, you need to find R equivalent. So how would you find R equivalent? For R equivalent, this input would be gone. 10 ampere UT would be gone. This would be 2Ix 5 ohm. 2Ix 5 ohm. And you need to find R equivalent here. And this is your 5 ohm resistance, right? This is 5 ohm. And this current is Ix. Bangalore में ठंड बढ़ गई है भाई. Yeah. So here I need to find R equivalent. So what I would do, I will apply a voltage source of VDC, right? I will apply a voltage source of VDC and get IDC out of it. So here what I can see, IDC is minus Ix, right? So if IDC is flowing like this will be giving me drop in this direction, this will be giving me drop in this direction, right? So VDC would be 2Ix plus 5 and 5, 10 IDC. 10 IDC, right? VDC would be 2Ix plus 10 IDC. Simple KVL I have applied, right? Because from here if I am going, this is plus, this is minus, this is minus, this is also minus. And 2Ix is negative of that, so it would be minus 2 IDC plus 10 IDC. So my R equivalent is coming out to be VDC by IDC, it is 8 ohm. So what is my tau? Tau or tau, whatever we call. Tau is L by R. What is L? L equivalent is 2 Henry. So 2 by R, that is 1 by 4 second. Okay. So what would be my V naught T? So my V naught T would simply be, from 0 to it is rising up to 31.25. 31.25 1 minus e to the power minus t upon tau. Tau is 1 by 4, so it is 40 ut. I am not really sure if this answer is correct. Let's just confirm it. Okay, how would we confirm it? We will confirm it with Laplace transform. Okay, applying Laplace transform. Method 2. Like, this is the first time I am solving it with the time domain actually. By Laplace I have solved, but I don't actually remember the answer. So let's just see if it is correct or not. So here I have a current source of 10 by S. Then I have a dependent voltage source, that is 2 Ix of S. I will write, and I should write it in capital actually. So 2 Ix of S, right? Like let's just assume if my input voltage is V in, I write V in S, not V in by S. Are you getting my point? Someone will think that I should have written like this. If my input voltage is 2 V in Laplace I would write 2 V in S. Let's just assume my input voltage is 2 into 5t. So my answer would be 2 into 5 by S square. So this is converted into Laplace. So simply Ix is converted into Laplace, right? Are you getting my point? So 2 into Ix, and then I have 5 ohm here. Like people will say that I have written 10 by s, but why didn't I write 2 by s I of s, or these kind of doubt you can get. But tan ut is simply 10 by s in Laplace, but it is 2 into some function, 2 into some function f of t. So I will write 2 into some function of Laplace of some function. Are you getting my point? This is 5 ohm. Then I have an inductor which has a impedance of 2s, 2s and 5 ohm. This is V naught S. This is Ix of S, right? Now I need to write V naught S. What is my V naught S? V naught S is 5 into Ix of S. This is equation 1. I just need to find Ix of S. So how will I find? Look, I can write KVL in this loop. KVL in this loop. How will I write? What is the current in this direction? What is the amount of current in this direction? Can you tell the value? From Ix of S, 10 by S is getting less. So the value of current here is Ix of S, and from that 10 by S is going that way, so rest of the current would be going that way. Right? So now I can write the KVL. So 2Ixs, from 2Ixx these many are there. So 2s into Ix of S plus 5 into Ix of S plus 5 into, what is the current in this? Ix of S minus 10 by S, right? 2Ix of S, 2Ix of X. Did I apply it correctly? Yeah, this is correct. No error, nothing is there. Well and good. Yeah. So 2Ix of S is there. From here we will get minus 10 Ix of S. From here we will get 2s Ix of S. Here we will get minus 50 by S. 8, 8 and 2s. So 2 here, 4 plus S. Right? So Ix of S, Ix of S equal plus 4. I'm doing the calculation right, I guess. It would be 25 by S. Right? Okay. Let's just solve it. So I was just thinking I am doing something wrong. What did I do here? So this is minus of 8Ix and minus of 2s Ix. Basically minus of 8 minus of 2s Is minus 50 by S. So 4 plus S I of S equals to 25 by S. Right? So I of S would be 25 by S upon S plus 4. Yeah, right. And what would be V naught S? So simply V naught S would be 25 into 5, 125, 125 by S upon S plus 4. What is 125 by 4? It is 31.25. So V naught S would be simply be 125, and here if I write 1 by S minus 1 by S plus 4, so at upper 4 will come, so here I can divide. So it would be 31.25 1 minus e to the power minus 40 ut. So this is what I am getting, V naught t. So this is also correct. So it was absolutely correct, nothing was wrong. Okay, in the previous analysis as well it was absolutely correct, but because there was nothing mathematical wrong here. First we found V naught infinity, then we found V naught 0, then we found the time constant. For finding the time constant, I can't simply calculate R equivalent because there is a dependent source. 2ix is the dependent source. For that I need to apply a voltage source of VDC and get IDC out of it, right? So from there I find R equivalent equals to 8 ohm, so time constant is 2 by 8. So this is what I got as V naught t, right? Then I could solve it by Laplace transform as well. So this is what I got solving by Laplace transform. Let's move on to the next question. You have to find the IT current in this. The switch is being closed at t equals to 0, but the input that is applied, that is DC, not ut, right? This is DC. The input that is applied is DC. What is the input? This is the input, 1.5 ampere. It is there for a very long time, right? So for t less than 0, steady state will be reached. The steady state will be reached. So basically this is not there because the switch is open and this is there. So basically (1.5 ampere). Look, I of 0 minus would be 0 ampere only because the switch is open. For t less than 0, the switch is open, so I of 0 minus would be 0 ampere only. Then why are we making the circuit? Because I of 0 minus will not be equals to I of 0 plus, right? I will just take this circuit downward. But I of 0 minus need not be equals to I of 0 plus. Why so? Because it is the current in the resistor, not in the inductor. The current in the inductor will be conserved. I of 0 minus would be IL of 0 plus because it is the current in the inductor, but this current is in the resistor, so it will not be conserved, right? It will be changed. So how it will be changed, that I need to see, right? A steady state will be reached. So if switch is open, that's why the current is 0 only, but the inductor will be shorted here. So this current would be also this will be shorted, but the current here would be IL of 0 minus. So IL of 0 minus would be 0.75 ampere. Are you getting my point? IL of 0 minus is 0.5 ampere. Now for t greater than 0, what will happen? IL of 0 minus will be equals to IL of 0 plus. That would be equals to 0.75 ampere, right? So at t equals to 0 plus, what is happening? Here I have 1.5 ampere current source, 10 ohm resistance, everywhere 10 ohm resistance is there. Then again I have 10 ohm resistance. In this 10 ohm resistance, there is, this is I of 0 plus. This is I of 0 plus. This is 10 ohm resistance, and here I have a 10 ohm resistance and an initial current of 0.75 ampere, right? And this is 10 ohm resistance. So from here I have 1.5 ampere, here I have 0.75 ampere. So what will be this I of 0 plus? Solve it on your own. Okay, I guess you will be able to solve it on your own, and the value would be 0.75 by 2. 75 by 2, that would be 0.375. How did I write it so quickly? What did I do? You can apply nodal as well. V by 10 plus V by 10 equals to 1.5 minus 0.75 ampere. Like V by 10 plus V by 10 plus 0.75 equals to 1.5. From there you will get the value of V, and from there you can get the value of I of 0 plus. How did I write? Here I thought 1.5 ampere, here I thought 0.75 ampere. So rest of 0.75 ampere would be going into these two circuits. these two resistance. 1.5 ampere is coming from here and 0.75 ampere is there. So rest of 0.75 ampere would be going into 10 ohm resistances. So this would be equally divided. So 0.375 ampere. So why was I interested in finding this current at t equals to 0 minus? At t equals to 0 minus, why was I interested in finding this current? Why was I interested? Because I knew that the current in the resistor will be changed at t equals to 0 plus, right? Because since the switch is being closed, here I am having some current, here I am having some current, so current in this will be changed. At t equals to 0 minus, it is 0 ampere, right? It is 0 ampere for t equals to 0 minus, but after t equals to 0 plus, it is changed. Now what will happen at t equals to infinity? At t equals to infinity, what will happen? Inductor open circuited, right? Sorry, shorted. Inductor short circuited. Inductor will be short circuited. So 1.5 ampere will be divided into 10 ohm, 10 ohm and 10 ohm. So I of infinity would be what? I of infinity would be simply 0.5 ampere. And if I am talking about IL of 0 plus, that would be 0.75 ampere, right? And here if I am talking about IL of infinity, that would also be 0.5 ampere, right? Because what is happening, this 1.5 ampere current is getting divided into 3 resistances. This is 10 ohm, this is 10 ohm, and this is 10 ohm in 3 resistances, that is 0.5, 0.5 and 0.5. Okay, so basically I can write down the expression for both of the currents. I of t, what will be I of t? I of t is 0.375. From 0.375 it is going to 0.5. So 0.5 to 0.375, so it would be 0.125 e to the power minus t upon tau ut. T upon tau ut. Tau we did not find yet. We need to find tau as well. So what will be time constant? So this is the circuit. What will be the time constant? Time constant will be R equivalent would be 10 in parallel with 10, 5 plus 10, 15. And what is L equivalent? L effective, that is 15 milliampere, right? What is tau here? Here I have 10 ohm. Here I have 10 ohm. 1.5 ampere current source will be gone, right? And this is, right? This is 10 ohm. This is 10 ohm. This is 10 ohm. And here I have 15 millihenry. So what is R equivalent here? R equivalent here is 15 ohm. What is L effective here? That is 15 millihenry. So what is tau? That is 1 millisecond, or I can write 15 millihenry by 15. That means 1 millisecond, right? And what is ILT? ILT would be, it is starting from 0.75 ampere to it is going to 0.5, right? Going to 0.5 and starting from 0.75 ampere. Okay, so tau is 1 millisecond. Here also the tau is 1 millisecond. You can make the graphs as well, but that's not required here. Okay, let's see this. You need to find the expression of current IT. Looks very simple problem. Okay, but there is one simple thing that you will understand here is that how the current will be divided. So initially the inductor will be what? Open circuited. So I of 0 plus would be 0 ampere. Initially inductor will be open circuited. So at t equals to infinity, what will happen? At t equals to infinity, inductor will be open circuited, right? So inductors will be open circuited. This is open circuited. Sorry, not open circuited, short circuited. Sorry, inductors will be shorted. This will be also shorted, right? And this is 1 ohm. So let's just assume this is ground. So what is the current here? 5 ampere. Now there is this 5 ampere current. Here we have current of 5 ampere. Now this 5 ampere current will be divided into L1 and L2. And how? In the inverse proportion. So I of infinity would be 5, that would be divided into 1 ohm, 1 Henry and 2 Henry. So in the inverse proportion, 1 upon 1 plus 2. So it would be 5 by 3 ampere, right? So I of t is simply going from 0 to 5 by 3 ampere, that is 1 minus e to the power minus t upon tau ut. So what is tau? Tau is L equivalent by R. So 2 by 3 second. Are you getting my point? What is happening? At t goes to infinity, inductors, both of the inductors will be shorted. So the current that is coming here is, that is 5 ampere. The current that is coming here is 5 ampere. Now 5 ampere has two paths, 1 Henry and 2 Henry, right? The inductor is shorted, that means it is providing very less impedance. Now both of the inductors are providing very less impedance. This is providing very less, this is also providing very less impedance, right? So it has to be divided in inverse proportion. The way we divided in the capacitor as well, we have seen this concept in capacitor, right? When we needed to divide the voltage at t equals to infinity, so we divided in the proportion, voltage in the inverse proportion. So this is the same thing that is happening here. Current will be divided in the inverse proportion of the inductance. Why inverse proportion? Because the impedance provided by the inductance is Ls. So it is the same as the resistance that we have seen in the basics of network. Like the resistance is same as the impedance provided by the inductance is same as the resistance. So in case of resistance as well, the current is divided in inverse proportion. In case of inductors as well, the current will be divided in inverse proportion. But in case of capacitor, the current will be divided in proportion, right? In case of resistance, the voltage is divided in proportion. In case of inductance, the voltage is divided in proportion. But in case of capacitor, the voltage is divided in inverse proportion. In basics of network, we have seen all this, right? So this 5 ampere is divided into 1 and 2. So basically 1 by 3 into 5. So 5 by 3 ampere current is that is flowing. Okay. Let's move on to the next question. You have to find the current at t goes to 0.5 second. Similar kind of question, you should try it on your own. The current in the switch at t equals to 0.5 second. So for t less than 0, steady state would have been reached. For t less than 0, steady state would have been reached. Why so? Because here I am applying 10 ampere current source, right? This is not 10 ut, so 10 ampere would be coming from t equals to minus infinity. Steady state would have been reached. So let's just call this as IL of 0, IL current we are talking. So IL of 0 minus would be what? This switch is open, so it would be 5 ampere, right? And this would be equals to IL of 0 plus. Now I of 0 minus is 0 ampere, right? Because the switch is open, the switch is basically open, so there is no current going through it, and it may not be equals to I of 0 plus. Now circuit at t equals to 0 plus. Circuit at t equals to 0 plus. Here I have 10 ampere current. Now there is very interesting thing, that's why I have taken this example. Here I have 10 ampere current. Here I have 5 ampere current. Here this is shorted, right? This is shorted, and here I have 5 ohm resistance and a current of 5 ampere, right? The current of 5 ampere. 5 ampere only, yeah, right. Now you need to, this is 5 ohm. Now you need to find the current in this branch, I of 0 plus. So I want you to tell me the value of I of 0 plus. What will be the value of I of 0 plus? Everyone should write down the answer. The answer would be 5 ampere. Why so? Because this 10 ampere current is coming from here. 10 ampere current is coming from here. This will see this resistance. No, it will not see, because this resistance is shorted. Right? This resistance is shorted. So there will be no current in this resistance. So this 10 ampere is here. Here I have 10 ampere. This 10 ampere was coming. This will see no. Here the voltage drop is 0 basically, because it is shorted. So voltage drop is 0. So there is 0 current. Right? So 0 current in this 5 ohm resistance. Why I am writing 5A? 5 ohm resistance, 0 ampere current. So 10 ampere current is here and 5 ampere current is here. So basically how much current is going in this branch? That is 5 ampere. At t equals to infinity, what will happen? The inductor will be shorted, right? At t equals to infinity, inductor will be what? Short circuited, right? Inductor will be short circuited. So what will be the circuit? 10 ampere current, 5 ohm resistance. This is the short circuit path. The inductor will be shorted, so it will only be replaced with 5 ampere. So tell me, what is the value of I now? I of infinity. I of infinity is simply 10 ampere. The complete current is flowing, right? And what is IL of infinity? That is 0 ampere. In inductor at steady state, 0 ampere current is flowing. And what is IL of 0 plus? It was 5 ampere. So in the inductor, 5 ampere to 0 ampere you are going, and in the switch you are going from 5 to 10 ampere. So what is IT? IT, you are going 10 ampere from 5 ampere. Okay, we need to find the time constant as well. So that also we will find. And what about ILT? In ILT, you are going from 5 to 0. 5 ampere to 0 ampere. Right? Now you need to find the time constant. So at t greater than 0, the switch is closed and the 10 ampere current source will be gone. So what is the time constant? 10 ampere current source will be gone. Okay, it is gone. Here I am left with 5 ohm resistance. The switch is closed. That means this is shorted, right? And now I have a 5 ohm resistance and a inductance of 2.5 Henry, right? 2.5 Henry, right? 2.5 Henry, and I have 5 ohm resistance. So tell me, what is the L equivalent here? L effective, not equivalent. L effective is 2.5 Henry. What is R equivalent? R equivalent from this node, right? From here, right? From here you are seeing R equivalent from this node. This potential is 0. This potential is also 0. Between 0 and 0, like let's just assume this potential is A, this potential is B. So between A and B there is only 5 ohm resistance, right? Because this 5 ohm is shorted. This 5 ohm is shorted. So R equivalent is only 5. So tau is 2.5 by 5. Look, we have solved a lot of problem in basics of network. So I guess you should be comfortable with all these things, right? So time constant is 5 ohm. 0.5 seconds, sorry. Because R equivalent is 5 ohm now. Because R equivalent is 5 ohm. Why so? Because this 5 ohm is shorted. So only 5 ohm is there. So R equivalent is 5 ohm. L effective is 2.5. Slowly, if you keep on solving more and more problem, you will be more comfortable with all these concepts. This everything we have studied in basics of network. So these are the expression of IT and ILT. Right? What did we do in this problem? Simple problem. First we needed to solve for t less than 0. For t less than 0, the switch was open. So basically at steady state, it will be having 5 ampere current. Now this 5 ampere current in the inductor will be carried forward. So at t equals to 0 plus, here I am having 5 ampere current, here I am having 10 ampere current. So in the short circuit path, I will be having 5 ampere current, and even in the inductor, the same current will be there. At steady state, the inductor will be shorted. So basically, this 10 ampere current completely flowing in the closed switch, because this is a complete short circuit path. So this complete 10 ampere current will be flowing there. So 10 ampere current, and in the inductor there will be 0 ampere current. So in case of IT, we are going from 5 to 10, and in case of inductor, we are going from 5 to 0. So this is the expression that we are writing. Okay, well and good. Let's move on to the next problem. So this is a very good problem. So we will be just drawing the graphs. You can write down the equation on your own now, because we have seen the problems of equation. Now we will just draw the graphs. Okay, it will take around 20 minutes, I guess. This problem will take around 20 minutes. So the circuit is given to you. Switch S1 and S2 both are closed for t for 0 to 0.125 second. Okay, and I should have written for t less than 0. For t less than 0, S1 and S2 both are open. Even if it is not given, we should consider them open as well. So both are open. Now at t equals to 0, both are closed. Okay, at t equals to 0, both are closed and remains closed till 0.125 second. When both were open, there was nothing happening in the circuit, right? Because this was one branch, this was one branch, and this was one branch, and no branch was connected, so nothing was happening for t less than 0. Now for t greater than 0, something will start happening, right? So this is the circuit I have copied. So for t 0 to 0.125 second. To 0.125 second, the switch is closed, right? Both switches are closed. So we need to comment on ILT and VLT. Okay, this is your VLT, this is your ILT, right? So tell me, at t equals to 0, inductor will be open circuited, right? Because there is 0 current. Inductor open circuited. So IL 0 plus is 0 ampere. What about VL 0 plus? If this inductor is open circuited, that means this 6 ohm doesn't come in action. So 6 by 9 into 18. That means simply it is 6 by 9. And this is a very simple problem. Actually, 2 by 3. 2 by 3. So 12 volt. How did I write 12 volt? Simple mathematics is there. This is open circuited. This is 6 ohm. This is 3 ohm. So 18 volt will be divided between 6 and 3. And whatever the voltage that is there across this 6, that same voltage will come across this inductor, because there is 0 current in this 6 ohm branch. So this 6 ohm branch will not have any voltage drop. So the same voltage that is there across this 6 ohm resistance, that will be coming across VLT. So VL at t equals to 0 plus is 12 volt. Are you getting my point? I hope you have understood, right? Open circuited. So 18 volt is divided between 6 and 3. So 6 will have how much voltage? 12, and 3 will have 6. Right? So this 6 voltage will come across the, sorry, this 12 voltage will come across the inductor, right? So VL of 0. Now at t equals to infinity. Now let's just assume the switch is closed at S1 and S2. Now the circuit doesn't know that one of the switch will be open after 0.125 second. The switch is closed at t equals to 0. So now the circuit will think, okay, the switch is closed and it will remain closed forever. So now it will try to go to steady state. But we are doing something at 0.125. We will just do something with the switches. We will turn off S2 and we will turn on S1, right? So but the circuit doesn't know. So what will circuit follow? Circuit will follow something like this. So it will try to be short circuited, right? So IL of infinity, what will be IL at infinity? So this is also simple mathematics that you can solve. So 6 and 6 will come in parallel. 6 and 6 will come in parallel, so it will be 3 ohm. 3 and 3 will be in series, that means 6 ohm. So 18 by 6, that means 3 ampere current will be going here. So this 3 ampere current will be divided into two resistance, 6 and 6. That means 1.5 ampere current in each resistance. So IL of infinity would be 1.5 ampere. So from 0 to 1.5 it is trying to go. And what about VL of infinity? VL of infinity will be 0 volt. So from 12 to it is trying to go down to 0. Now tell me, what is the time constant? What is the time constant? So time constant of this circuit is this 6 and 3 will come in parallel, right? What is L effective? That is 1 ohm. What is R equivalent? R equivalent will be 6 and 3 will come in parallel, right? Plus this 6 ohm, because you will find equivalent resistance here. So 6 ohm plus 6 and 3 in parallel. So that would make 6 and 3 in parallel will make 2. So basically it is 8 second. Not 8 second, 8 ohm, sorry. 8 ohm. So time constant is L by R 1 by 8. That is 0.125 second actually. Okay. So time constant is 0.125 second. So in 0.125 second, the steady state will not be reached. The steady state will be reached in 0.125 into 5. That means in 0.625 second. So steady state will be reached in in 5 to, that is 0.625 seconds. So how is the circuit behaving? Let's just see. We will make the graph of ILT as well, and we will make the graph of VLT as well. So ILT is going from 0 to 1.5. It is trying to go to 0, from 0 to 1.5, but it will not go, right? We are making the graph for ILT and VLT. What is happening in case of VLT? VLT is trying to go from 12 to 0 volt, right? So this is for ILT and this is for VLT. Zero to 1.5 ampere it is going. So it is going like this, from 0 to 1.5 ampere. Zero to 1.5 ampere, right? The calculation is right now. 3 ampere, yeah, 1.5. So 0 to 1.5 ampere. 1.5 ampere. So this time window will be nearly 0.625. But at 0.125 we are doing something, right? 0.125. But at 0.125 we are just doing something here only. Let us assume this. So after this it will not follow that waveform. Whatever the current value it is there, let's try to find at 0.125 what will be the value of current. So IL of t would be, from 0 to it is going to 1.5, 1 minus a to the power minus t upon tau, where tau is 0.125 second. So IL at 0.125 second is what? What is the value? Minus 1 plus minus into 1.5. That would be 0.948 ampere. Okay. So this much of current we are having. Okay. 0.948 ampere. And what about this voltage? From it was 12, then it is trying to go to 0. From 12 to 0 it is trying to go. From 12 volt to it is trying to go to 0, but somewhere here this will be your 0.125, right? Now I am not interested in finding this value. Why is it so? I am not interested in finding the VL value at t 0.1. I am not interested in finding this value, VL value at 0.125. I am not interested in finding this value. Why so? Because I just need to make the graph, and and the inductor doesn't have the property of storing its voltage. It will store its current, right? So this current will be carried forward. The current that I am getting, this current will be carried forward, but voltage will not be carried forward. Voltage will be changed. Now what is happening? Now, so that's why I am not interested in finding this voltage. Now at t equals to how much time? 0.1125 second. Which switch is open? Switch S2 is off and switch S1 is closed. Switch S2 is open and switch S1 is closed. Now IL of 0.125 minus would be equals to IL of 0.125 plus as well, because this will be carried forward. That would be 0.498 ampere, right? So now what is the circuit? First that we need to see. 6 ohm, 6 ohm, 1 ohm, 1 Henry. So 6 ohm, 6 ohm, 6 ohm and 1 Henry. How much is the current? 0.948. That is the initial current. Tell me where it would want to go. Tell me. So it would try to go to 0 ampere, right? What is this? This is your ILT and this is your VLT. So this is simply this circuit, a resistance and an inductor. What happens in this? The inductor is having some initial current I naught and this is inductor. So what happens in this? We have studied this, right? Initially it will have some current and the current will try to go down to 0. Also the voltage will also be 0, because at steady state what happens? The inductor acts as a short circuit. Because this is short circuit, the voltage across the resistance will be 0. So basically the voltage across the resistance is 0, voltage across the inductor is 0, also the current in the inductor is 0, current in the resistance is also 0. So both voltage and current will go to 0 because there is no source involved. No source is involved, that means no voltage source or current source. So that means simply both of them will try to go to 0. And what is VL at t equals to 0? What was VL at t equals to 1.5 minus 0.145? We don't know. But VL at this value will not be equals to VL at 0.125 plus, right? What is the VL value at 0.125 plus? Everyone should write. Think about it and write. What is the value? That is minus 12 into 0.948. That's why I was interested in this current. The voltage, this voltage drop will be equals to minus VLT. This 0.948 current is flowing at, this is a circuit at t equals to 0 plus, at t equals to 0.125 plus, sorry, not 0 plus, 0.125 plus. So now from what is happening? The circuit is, the 0.948 current is flowing through this 6 ohm resistance as well and this 6 ohm resistance as well. So 0.948 into 12. So 0.948 into 12. So minus 11.37 is the voltage we are having. And both of the voltage will try to go to 0. So this voltage will also try to 0 at t equals to infinity. So what will happen? It will all will try to, what will happen? This inductor will be shorted, right? And there is no current that is there, no source is there, nothing is there. So the VL at t equals to infinity will also be, this is VL at t equals to infinity and this is IL at t equals to infinity. So VL at t equals to infinity will be 0 volt, IL at t equals to infinity will also be 0 ampere. So started from some value. What was IL at t equals to 0? IL at t equals to 0.125 plus, that was 0.948 ampere. So both are trying to go to 0. So let's just write the equation for ILT. Actually I don't need to write the equation, but let's just write it. Or shall I write it? What is the need of writing the equation? For current, I will write it. Why so? Why I am writing for current? From 0.9482, it is going down to 0. E to the power minus t upon tau. But here I will write t minus 0.145 to tau because I am starting from 0.125. Okay. Now what is the time constant? Let's just talk about time constant as well. What is the time constant? What is the time constant? What is L effective here? 1 Henry. 1 or 1.5 it was? 1. Okay. L effective is 1 Henry. What is R equivalent? R equivalent is 6 and 6 in series. So it is 12 ohm. So what is tau? That is 1 by 12. So what is nearly 1 by 12 is? 1 by 12 nearly is 0.083. 0.083 second into 5. It will take 0.4 second to reach to the steady state. Right? Since I can write it here. Since tau is equals to 0.083, it will take 5 tau. That means 0.42 second to reach steady state. Right? So, but again after 0.125 second, right? From 0.125 to 0.250. That means after 0.25 to 0.250 second, we are doing something different as well now. Right? After 0.25 second, what we are doing? We are making S2 on and S1 off. So again, steady state will not be reached. So what they are trying and what actually will happen, that we will see here. So this is the expression for ILT, right? The equation is not needed actually. So for ILT, and for VLT as well, we will make the graph. Okay. So this is ILT. This is VLT. So what about ILT? It will start from 0.948. 0.948 and it will try to go down to 0. But something will happen at t equals to 0. What is the expression of ILT? That is 0.948. From 0.948 ampere it will start and it will try to go down to 0. But it will be there for 0.125 second only. What is the time constant here now? Tau is 1 by 12. So if tau is 1 by 12, so I will write 12 here. So 0.125 into 12 plus minus e to the power minus 1 plus minus into 0.948. So the current will be gone to 0.736 ampere only. Right? This is the value of current at 0.250 second. Right? The value of current at 0.250 second. Now we will comment on VLT. So VLT is going from minus 11.3 second to, so basically VL is minus 11.37 volt to, it is trying to go down to 0. Right? But it will, so minus 11.37. to 0 volt. But I am not really interested in finding the magnitude at t equals to 0.125 second. Why I am not interested in finding the magnitude? because the voltage will not be conserved, right? The current will be conserved. So the current value is 0.736 ampere. Now at t equals to 0.25 second, S2 is on and S1 is off. The current will be carried. So IL at t equals to 0.250 minus would be equals to IL at t equals to 0.250 plus, that would be equals to 0.736 ampere. So what will be the circuit at t equals to 0.250 plus? Now what will be the circuit? The S2 is closed, S1 is open. 6, 3, 18 and 1. 18 volt 631, 18 6 361, 18 361, 18 volt 3 ohm, 6 ohm and 1 ohm. This is your VLT, this is your ILT, your ILT. Here you are, instead of this inductor, what you can do, you can make a current source, and that is of how much current? That is of 0.736 ampere. Now what will be VL at t equals to 0.250 plus? That would be 0.736 into 9 minus 18 minus this value. So basically it would be 11.37 plus 11.37 it would be. Surprisingly plus 11.37 it is coming. So what I am doing, this same current is flowing through this 6 and 3 ohm. So basically 0.736 into 9. So basically the voltage drop in this direction is in this direction. There will be voltage drop in this direction. So the total voltage drop in this direction would be 6.624. So 18 minus 6.624 is your VL this. So basically this is 0.736 into 9. So it is coming out to be 11.37 only. So now VL at t equals to 0.12, VL at 0.250 plus is not equals to VL at 0.250 minus, right? Now tell me what will happen at steady state at t equals to infinity. What will happen? What will be the value of IL at t equals to infinity? The inductor will be shorted. So IL at t equals to infinity would be 2 ampere. What will be the VL at t equals to infinity? That will be 0 volt, because the inductor will be shorted. So it would be 0 volt. Since there is this 18 volt source, that's why we are having this 2 ampere current. If this source was not there, we will be having 0 ampere current only, right? So now we are going from, yeah, and this is VL at t equals to 0. What is IL at t equals to 0.250 plus? What is the value of IL? That is 0.736 ampere. It is 0.736 ampere. So from 0.736 ampere to we are going to 2 ampere, right? So what is the expression of ILT? And time constant also we need to find. Time constant also we need to find. What is the time constant? Time constant is L by R. L is 1, R is 9. 6 plus 3, 9. So this is the time constant. This is the time constant. So what will be your ILT? ILT is starting from this. So 0.736 minus 1.264. What did I do? I just found the value of IL at 0.250 minus, sorry, IL at 0.250 plus minus IL of infinity. So this is value I am getting e to the power minus t upon tau, but instead of t I will write t minus 0.250 upon tau, right? And what will be your VL of t now? VL of t is 11.372, it is going to 0. It is going to 0, right? So this is what is happening. So now I can make the complete graph, I guess. This I am making for VLT, this I am so this was for ILT and this will be for VLT. For ILT, what was happening? First graph 0 to it is rising up to some value that is 0.948. 0 to rising up to some value that is 0.948. Then what happens? Then it drops down from 0.948 to 0.736. Zero point 0.948 to 0.736. Then what happens? From 0.736 to 0.736 it is rising up to 2 ampere. From 0.736 to 2 ampere. For each cycle, the time period is different. What is the time period for first one? Time period for first one was, where did we calculate? It was 0.125, right? Time period also we need to highlight 0.125 second. 0.125, then for the second one it was 0.083. So it was 0.125 time constant. First let me make the time windows. This was 0.125 second. This was 0.250 second. Time constant was 0.125 second. Here the time constant was 0.083 second. And here the time constant is 1/9, right? Time constant is 1/9. What is the value of 1/9? That is 0.11. 0.11 second, right? This is the graph of ILT. Now we will make the graph of VLT. So what is happening in case of VLT? From 12 volt to it's dropped down to, from 12 to it start dropping down to some value, but the value we have not written actually. Yeah, so from 12 to it starts to drop down. You can make the graph on your own actually, right? You don't need to wait. From 12 to it is dropping down to some value that we don't know, right? Then then what happens? Then at t equals to 0.125, it suddenly drops to some value, and that value is 11.37, minus 11.37. That value will be somewhere here. So it suddenly drops like this. It should go more down actually. Somewhere here. Minus 11.37. This value I know, that is minus 11.37 volt. Right? Then from minus 11.37, it tries to go to 0, but it can't go till that point. Tries to go to 0, but it can't go till that point. Right? So it goes to this much of value, then it suddenly rises to this 11.37 volt. Right? This should be highlighted. It is rises to 11.37 volt. Rises to 11.37 volt, and then finally decays down to 0. Right? So this is what is happening in the circuit. This is 11.37, and then finally decays down to 0. So this is what is happening in this circuit, right? And this time period was 0.125, this was 0.250, right, in the second. The time constant has been the same, 0.125 second, 0.083 and 0.11 second. Got it? Now in the exam they are not going to ask you this much of big question, but they can ask you the waveforms. So what you will do in the exam? Okay, so this question comes in your exam and they are asking you the waveform, and you have 4 options. You will be having 4 options for the waveform. So what you will do? First you will think both of the switch are closed. Then you will do some kind of calculation and you will get to know that the current will rise and it will try to go to some value. Okay. Then you will make the graph. Then you will see that S1 is closed, S2 is off. Now the current will try to go down to 0. So that graph you can make. Then you will see that again this is closed. So the current will rise up. So you can make the graph very quickly. You don't know the values. You can make the graph. First it will rise. But since that is closed and now only inductor and resistance we are having, no source. So the current will try to go down to 0. Then again it is closed, then again it will rise. Same in case of voltage. From 12 it will start, it will try to go down to 0. So from 12 it will start. From 12 it will start, it will try to go down to 0. But since it cannot go to complete 0. But one thing I know is that there will be some current flowing in the inductor in this direction. If the current is flowing in this direction, that means surely I will be having a negative voltage. Now this negative voltage will try to go down to 0. Are you getting my point? I know that the current will be flowing in the inductor in this direction, and now when S1 is closed, I am having no voltage source, only resistance and inductor, and the current is flowing in the opposite direction in the resistances. So my VLT would be negative. So from some negative value, I will try to go to 0, but I can't go to 0. Then again, I will be having some current, and because of that current, I will be having again positive voltage, and that voltage will try to go down to 0. So this is what is happening in the circuit. So that's how you can make the graph very quickly, right? You will not have to, for graphs, you will not have to like do any calculation. If you are just very good enough with the concepts, then I don't think you need to do any calculation. Just by the option, you can tick the final answer. Are you getting my point? Once revise this question, if you revise it nicely, you will get to know everything. Okay, let's move on to the next question. So in this question, you have to find the time constant for t greater than 0. Okay, I want you to solve it on your own. For t greater than 0, what will happen? This will be gone. So there is no use of this circuit. This is just to give, this is given just to confuse you. So for t greater than 0, this will be gone, only this circuit will be there. So basically this Vx by 3, all those similar kind of question we have solved in this exercise only. First question was like this only. Now I am just asking you the time question, nothing else. This is 10 Henry and this is your Vx. Now tell me, what is my L effective? 10 Henry. What is my R equivalent? This will be shorted and R equivalent is 1 ohm. Is it correct? No. This is right, but R equivalent is not 1 ohm, right? Because this is not a independent source, right? This is a dependent source. You can't short circuit it. So this will remain there as it is, Vx by 3. This will be 1 ohm. You need to find R equivalent here. So what you will do? You will make VDC and will get a current IDC out of it. So here your Vx is equals to VDC and VDC minus Vx by 3 is equal to IDC into 1. So basically 2 VDC by 3 fine 2 VDC by 3 is equals to IDC. So R equivalent is simply 1.5 ohm. Let me just check if I have done the calculation right or not. This is VDC minus Vx by 3. So 2 VDC by 3 is equals to IDC. So 3 by 2. Yeah. So R equivalent is 1.5 ohm, not 10 ohm, not 1 ohm. Okay. So what is my tau now? Now my tau would be L effective by R. So that would be 10 by 1.5. Whatever value we get, 10 by 1.5, 20 by 3, it should be around 6.66. 10 upon 1.5, 6.66 second. Okay. This will be 6.66 seconds. So I hope you liked the exercise. I hope you have solved all the questions. This was very easy question. Just I needed to tell you that R equivalent can be found like this when there is dependent source is given. Okay. This question was very good. Then we solved this question. The current in the switch, right? And then the current was being divided. And in this question, the current in the switch again we found, right? In the first question, we solved by Laplace as well and by time domain as well. While doing the time domain analysis, we just took at t equals to 0 inductor is shorted. Then we found the value of V0 simply by network analysis, and at t equals to 0, the inductor is open circuited. So V0 is 0 volt. And what is L time constant? So for that, we needed to find the value of R equivalent. So R equivalent we found like this. Not just like this is shorted, so R equivalent would be 10. No, R equivalent is not 10. Why so? Because this is not an independent voltage source. This is a dependent voltage source. So for dependent voltage source, we have to find the value of R equivalent, and we found the value of R equivalent. Then we got to know the V0T. So these are the questions. I hope you have liked the lecture. In the next lecture, we will be solving. I don't really know what we will be doing in the next lecture. I can bring one more exercise, or we can study about RLC circuits as well. So I think we will study about RLC circuits. Then we will bring one more exercise or two more exercise together, right? So after RLC circuits, what we will be left with? LC oscillators, and after that sinusoid response. Then our transient will be over. So I guess around 4 hours of theory is there. 4 or 4.5 hours of theory is there. Around 4 to 4.5 hours of theory is there. Rest will be the questions only. Okay. Then transient analysis will be completed, and every single concept is known to you, right? Okay, then let's meet in the next video.